titration curves of weak bases versus strong acids. The titration of a weak base with a strong acid is the reverse of those for a weak acid versus a strong base. زي ما خدنا زمان التitration curve of strong acid sample against strong base، وقلنا ان السترونج بيز سامبل against strong acid هي دي الميرور ايمج بتاعتها، وشفنا شكل الكيرفين قصاد بعض. برضو بالنسبه للويك سامبلز، الويك بيز when titrated with a strong acid it is the reverse or the mirror image of the titration curve of a weak acid versus a strong base. The titration curve for 0.1 molar ammonia titrated with 0.1 molar HCl is a very well-known example for weak basis sample. It is shown in the following figure. The neutralization reaction for this titration is ammonia plus HCl will give ammonium chloride salt plus water. This figure shows the titration curve of sample 0.1 molar ammonia titrated with 0.1 molar HCl. We can see the shape of the titration curve. The sample here is a basic sample, so the titration curves begin from above. You can notice the difference. Very obvious when the sample is a basic sample, either a strong base or weak base, or the sample is an acid, either weak acid or strong acid. In case of samples acidic, the titration curves at the beginning begins from a very low pH. Okay, when the sample is basic, the pH start from higher pH values, so starts from above, from the titration curve scale. Okay, the y-axis scale, the pH have higher values in case where the sample is basic samples, either weak or strong base. Okay, we can see in this titration curve that at the beginning of titration we have 0.1 molar ammonia, and the pH is calculated using the equation for weak bases. pH is equal to 14 minus half pKb plus pCb. Then we can see the buffer region, the formation of the buffer region, as we explained previously in the case of sample acetic acid. Here also in the case of ammonia sample, there will be formed a buffer region, okay, as some of the ammonia is converted to ammonium salt during titration. So a buffer region is formed. At the midpoint of this buffer region, the molar concentration of ammonium is equal to the molar concentration of ammonia. And so the pH at this point is equal to the pKa, or pH is equal to 14 minus pKb. Okay, at this point of midway the buffer region. At the equivalence point, we have a solution of ammonium chloride. Solution of ammonium chloride, of course, it is a salt coming from a weak base and a strong acid. It will undergo hydrolysis to give an acidic solution. The pH of this solution will depend, of course, on the concentration of the salt. Greater concentration will give lower pH. Okay? Beyond the equivalence point, the ionization of the proton will be suppressed, and the pH is determined by the molar concentration of the hydrogen ion coming from the excess HCl. But the ionization of ammonium chloride will be suppressed. Okay? Beyond the equivalence point, the ionization or the hydrolysis of ammonium chloride will be suppressed, and the pH is only controlled by the proton ion or the hydrogen ion coming from the excess titrant, from excess HCl. Okay? Because Kb for ammonia is equal to Ka for acetic acid, The titration curve for ammonia versus a strong acid is the mirror image of the titration curve for acetic acid versus a strong base. The indicator for such a titration must have a transition range within about 4 to 7. Methyl red meets this requirement, so methyl red can be used for this titration. If phenolphthalein have been used as indicator, it changes its color between pH 10 and 8 at this range before the equivalence point was reached. يعني هيغير لونه قبل ما نوصل للايكويفالنس بوينت اصلا. يبقى ينفع ولا ما ينفعش؟ طبعا ما ينفعش. يبقى phenolphthalein cannot be used for this titration. What is the preferred or the optimum indicator? Methyl red. Methyl red can be used for this titration, while phenolphthalein cannot be used. Now we will summarize what we have already said of comments on the titration curve of ammonia. At the beginning of titration, we have 0.1 molar ammonia, and pH is calculated as for weak bases. As soon as some acid is added, some ammonia is converted to the salt, ammonium salt, and we are now in the buffer region. At midpoint of the buffer region, the molar concentration of ammonium salt is equal to the molar concentration of ammonia, and pH at this point is equal to 14 minus pKb. Okay, at equivalence point, we have a solution of ammonium chloride, which undergo hydrolysis to give an acid solution. pH will depend on its concentration. Greater concentration will give lower pH. Beyond the equivalence point, the ionization will be suppressed of the salt, and the pH is determined by the molar concentration of hydrogen ion coming from the excess added titrant HCl, the strong acid used as titrant. Okay.